Welcome back, Algebra students. I hope you're doing well today. So we are going to talk about 9.6, which is the quadratic formula. Today is a very exciting day. Let's begin with the ways that we know already of how to solve quadratics. If any of you hear that knocking noise, Mr. Avard is up on the roof trying to fix a leak. So that's what that is. All right. So the first way is like problem number 1 that you had on your quiz. When you have a quadratic that has an x squared term but no x term, then these are easy peasy. You're like, yay, I know how to do that. We just are going to isolate the x squared and take the square root of both sides. I'm going to do this quickly. We would subtract 5. We'd have 2x squared equals 50. We're going to divide by 2. We're going to have x squared equals 25. And then we're going to square root both sides. And don't forget the plus or minus. X can be plus 5 or minus 5. All right, that's the first quadratic. The second way that we learned to solve a quadratic is if we have all three terms, x squared plus 5x plus 6 equals 0. And one way, the first way we learned, was to factor this. So we could factor this. We want two numbers and multiply to 6 and add up to 5. Do you know what those are? I hope you said 2 and 3. They're both plus. And then we apply the zero product property, which means that if x plus 2 is 0 or x plus 3 is 0, then their product is 0. So x is a negative 2 or x is a negative 3. And if you plug those in, negative 2 squared is 4, minus 10 is negative 6 plus 6 is 0, negative 3 squared is 9, minus 15 is negative 6 plus 6. They both work. Yay, every quadratic has two solutions. Another way that we solved was by graphing. And graphing was a pain in the neck, right? Unless you can get it into vertex form, and then you know that your two answers are negative 2 and negative 3, and you'd have some sort of parabola that graphs like this, right? Ooh, yes, 6, 1, 2, 3, 4, 5, 6. That's how this guy graphs. But if you don't have the intercepts and you're just graphing from negative b over 2a and it's approximate, this is a pain. This way is a pain in the neck, and it's also not very accurate. The important thing and why we do this is so that when you look at a graph and you see the x-intercepts, you know those are the same as the zeros, the roots, the solutions. All right. The fourth way that we learned to solve quadratics was by completing the square. And on the previous bonus video, I went through one of those, so I'm not going to do one of those right now. But the way that always works and the way that you are going to use the most, besides factoring, because you will factor quite a bit, but the way that always works when you go on and do science, physics, things like that, you are going to use almost all the time the quadratic formula. The quadratic formula, it's a big deal. So what is the quadratic formula? Well, when you look at it, it looks nasty, but I like to sing a song. It helps you remember how it goes. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we were in class, I would make you sing it out loud like I have with my other algebra students. But some people sing this to the Hail to the Victors, but since I'm a Sparty, I like the Pop Goes the Weasel tune. Where do the a, b, and c come from? They come from ax squared plus bx plus c, and then it's simply a plug it into your calculator and chug it out. So how easy could that be? Well, it only messes up when you do the order of operations wrong, or this little guy right here. Do you see b squared? A lot of people forget to put parentheses around b when he's negative when you square it. All right, let's do a couple of examples. Here we go. The first one is 3x squared plus 5x equals 8. Number one step, you have to get everything on one side equal to 0. So we have 3x squared plus 5x. That's going to be a minus 8 equals 0. And I noticed that some of you were confused on the test with what's A, B, and C. So here's A, here's B, and here's C. All right, what are the solutions to this? X is equal to negative B plus or minus the square root of B squared minus 4AC, don't forget the negative, all over 2A. All right, now let's take a look at the order of operations. I want to go underneath the radical and figure out what this is first. And you could plug it in exactly like this. Let me see. Hopefully you can see the screen of my calculadora. So I've got 25. I'm sorry, I'm moving it all around on you. How annoying. 25 minus 4 times 3 times negative 8. 121. Ooh, I did not leave myself enough room here. So we have negative 5 plus or minus the square root of 121 all over 6. If you're wondering what kind of work do I want to see on your homework and your test, it's this exactly. What's the square root of 121? That's 11. Negative 5 plus or minus 11 all over 6. And now we got to break this down and do this 2 times. Negative 5 plus 11 is 6. Negative 5 minus 11 is negative 16. So if we divided both by 2, this would be negative 8/3. And there we are. Those are the 2 roots, the 2 solutions to this quadratic. If we put them in here, they would both be equal. We could check the 1 real quick. 3 times 1 squared is 3, plus 5 times 1 is 5. 3 plus 5 is 8. That works. Negative 8/3 is a little bit trickier, but I guarantee you it will work. Let's do another one. Starts out looking like this. 2x squared minus 7 is equal to x. Remember, we want it to look like this, equal to 0. So we need to get every term on the left, and then I'm going to put them in the right order, right? So what is A? A is 2, B is negative 1, and C is negative 7. Now we plug and chug. X is equal to negative B. Well, if B is negative 1 and negative 1, it's positive 1. This is where you're going to go wrong. It's okay. Just be careful of your signs. Plus or minus the square root of B squared. B squared is always positive because any number squared is positive. Negative 1, it's a negative 1 quantity squared. If I wrote it out, it'd be like this. okay? And that's a positive one. Some of you missed that on the quiz. You gotta be careful. There's b squared minus 4ac all over 2a. And then let's grab your calculator. Now, here's my hint to you. I can do that in my head. If I did on the calculator -1 squared, guess what I get? That's not right, correct? So if you are going to do it on the calculator, you got to use your parentheses, -1, and square that, which is a +1. So that's just annoying to me. So I'm just going to do this in my head. 1, and then you could multiply these together if you want. 28 and 2 is 56, or you could do it all on here. But 1 plus 56 is going to give me 57. 1 plus or minus the square root of 57 all over 4. Okay, what do we do with a number like this? I don't want you to get confused with this other. We're looking at this right here. In higher mathematics, bada boom, bada bing, you'd be done, because the square root of 57 is an irrational number. When you take physics, you would want to get an approximation for this. So we would actually go ahead and do 1 plus the square root of 57, 1 plus the square root of 57. Make sure you equal that out, divide it by 4. And if we wanted to round this to 2 decimal places, 2.14. So we have approximately 2.14, whoops. Or, now we have to do 1 minus the square root of 57. 1 minus the square root of 57. Equal that out. Divide that by 4. And we would get a -1.6. I guess I would, since I rounded this to 2 decimal places, we can round that to 2 decimal places. This is the exact answer. If you're a mathematician, you'll see this. If you go into physics, this is an approximation. Or if we're doing word problems, this is how you approximate it. Alrighty, I was going to go over the problem in the book. I think you guys can try that on your own. Here's your homework. Number 45 is a challenge problem. The first person that can email me with a right answer will get extra credit on the Chapter 9 test. All right, I hope you're up to the challenge. See you next time.